So lesson 19.1 is on basic exponent properties. So we're going to talk about two properties today. We're going to develop basic exponent properties and simplify expressions involving exponents. An iceberg is a large piece of freshwater ice that's broken off from a glacier or ice shelf and is floating in open seawater. Icebergs are classified by size. The smallest sized iceberg is called a growler. A growler was found floating in the ocean just off the shore of Greenland. Its volume above water was approximately 27 cubic meters. So two icebergs float near the growler. One iceberg has a volume of 3 to the fourth times greater than the growler, and the second volume is 2 to the eighth times greater than the growler. Which iceberg has a larger volume? So to compare, we would say, well, 3 to the fourth and 2 to the eighth. And so 3 to the fourth is 81, and 2 to the eighth would be 256. So 256 is greater. So the iceberg that is 2 to the eighth times greater would have a greater volume than the one that's 3 to the fourth. So what is the meaning of 3 to the fourth and 2 to the eighth? And why do you think exponents are used when writing numbers? Well, exponents are used to show repeated multiplication. So if I'm writing it as repeated multiplication, 3 to the fourth is 3 times itself 4 times, and 2 to the eighth is 2 times itself 8 times. 6, 7, 8, and they're all being multiplied together because that's how we arrived at 81 and 256. So suppose the original growler's volume under the water is 9 times the volume above. How much of its ice is below the surface? So if we take the 27 that it was times the 9, then that gives us 243. So that means that 243 cubic meters would be under the surface. Write your solution to item 3 using powers. Complete the equation below. Write the missing terms as a power of 3. So a power just means that we're writing it in exponent form. So we've got the volume above water times 3 to the second equals the volume below the surface. So 3 to the third would be equal to 27. So then that becomes 3 to the fifth power, because 243 is 3 times itself 5 times. So looking at the equation we completed, what relationship do you notice between the exponents on the left side of the equation and the exponent on the right? Well, when the bases are the same, we keep the base and we add the exponent. So the base was the 3 of each of these, and the exponents are the small numbers. So if we have the same base, we can add 3 plus 2 to get 5. So this is the shortcut. Instead of multiplying it all the way out, we can look at it from exponent form and add them together. This only works, though, whenever the base numbers are the same. So for example, if I have 2 to the fourth times 2 to the sixth, that's equivalent to 2 to the 10th. And as you're working through these, be sure to pause the video at any point that you need to, so you can go back and make sure you've got everything written down, or listen to something so that you're understanding what it means. Alright, so the next page says, use the table below to help verify the pattern you notice in item 5. First, write each product in the table in expanded form. So this is expanded form, that's the repeated multiplication. Then express the product as a single power of the given base. The first one's been done for you. So, I just used the exact same example. So, or not the exact same, but close. So 2 to the second times 2 to the fourth. 2 to the second is 2 times 2, and 2 to the fourth is 2 times 2 times 2 times 2, which there are 6 2's, so that's the same as 2 to the sixth. So in other words, we add the exponents and keep the base. So 5 to the third becomes 5 times 5 times 5 for the first 3, and then times 5 for the second, which then gives us, adding it together, 3 plus 2 is 5, so we have 5 to the 5th. This works the same for exponents. So if we have x to the 4th, then we repeat the x 4 times. So x times x times x times x. And then we have 7, so times x times x times x. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So then again, we have now 11 x's. So x to the 4th times x to the 7th is equivalent to x to the 11th. So again, just because the variable changes letters doesn't mean it changes the rule. And so the bases are the same. They're both a's, so 6 plus 2 is 8. So if you were going to write it out as the expanded form, you just have a times 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 a. So we've got 8 total a's. So the next one we have, number 7 is based on the pattern you observe in the table in item 6. Write the missing exponent in the box below to complete the product of powers property. So a to the m times a to the n is a to the mn, because we multiply them together, so it's just in variables written next to each other. So that just goes back to what we said a while ago, is when the bases are the same, add the exponents. Oops, I forgot the plus sign between them. So I misspoke a while ago, so that's m plus n, not m times n. All right, so this is what we call the product of powers property. So that's really important to remember that name, product of powers. So that means we are multiplying powers, and powers are bases with an exponent. It's the whole thing together is that power. So if we're multiplying two bases that are the same, then we add the exponents. A side note here is that if we have the number 2 by itself, that actually has an exponent of 1. So any base that's just sitting by itself, whether it be a variable or a number, if it doesn't show you the exponent, it's really there in the form of a 1. All right, so back to number 8. Write x to the 3/4 times x to the 5/4. So if we follow our rule, our base stays the same and becomes one base, and we add 3/4 plus 5/4 to get 8/4, which equals 2. Well, that was sloppy handwriting, sorry. And so that then becomes the same as x to the 2nd, or x squared. So density, I know you've studied density in science, and so we know the formula for density is mass over volume, and you'll probably start to sing the song that you know from science. But this is relevant to us here today too for exponents, because a lot of times density is very large or very small numbers that's representing the mass and the volume. And so exponents can come in handy to help you write the numbers smaller than what they already are. And so if we have 5,949 kilograms as our mass and our volume is 81 cubic meters, we would say density equals 59,049 divided by 81. And if we plug that in, 59049 divided by 81, that gives us 729. So that means that our density would be 729 kilograms per cubic meter. Now it says write the solution in item 9 using powers of 9. Well, we know that 81 is 9 to the 2nd power. And if you're uncertain of what 59,049 is, we can plug it into the calculator. So 59,049. And if we keep dividing it by 9 until we get down to 1, however many times we have to divide it by 9 will tell us what our exponent is. So divided by 9 once, twice, let's start that over. Sorry about that. 59,049 divided by 9, divided by 9. Oh, I keep hitting the wrong button. Darn it. 59,049 divided by 9 equals, divided by 9 equals, divided by 9 equals, divided by 9 equals, and divided by 9 equals 1. So that means that it is equivalent to 9 to the 5th power, and 9 to the 5th power divided by 9 to the 2nd power is the same as 9 to the 3rd power. And so if we have 729 divided by 9, divided by 9 again, and there's our third 9 divided by 9 to give us the 1. So or working backwards, we can say 9 times 9 times 9 is 729. So 9 to the 3rd power is equivalent to 729. So what we can do is write these larger numbers with exponents. And so what do you notice about 9 to the 5th divided by 9 to the 2nd becoming 9 to the 3rd? Well, our bases are the same, so we subtract the exponents. So let me give you another example. So if I have 10 to the 6th power divided by 10 to the 3rd power, that would be 10 times itself 6 times. 4, 5, 1, 2, 3, 4, 5, and 6 divided by 10 to the 3rd, which is 10 times 10 times 10. And so for every 10 on top, it cancels out a 10 on the bottom, or reduces out. So we're left with 10 times 10 times 10, which is the same as 10 to the 3rd. Or in other words, 6 minus 3 is 3. So when we are dividing exponents, because the fraction bar tells us division, we keep the base the same and we subtract the exponent. So again, to divide exponents, keep the base the same and subtract the exponents. Again, feel free to pause the video if you are not caught up with anything, or if you need to pause it as you go, just keep doing that as you are working through. So let's continue on. And now we're going to look at it, what I just explained as well, but from an expanded notation here. So use it to verify the pattern. So 5 to the 8th again is 5 times itself 8 times. So 5 times 5 times 5, 5, 5, 5, 1, 2, 3, 4, 5, 6, 7, and 8. And then that is all over. Whoops. 5 to the 6th power, so we're going to repeat our 5, 1, 2, 3, 4, 5, 6. And so again, every time we have one set, that divides out, and so we're left with 5 times 5, which is 5 to the 2nd power, because 8 minus 6 is 2. So A times A times A divided by A, and there's that 1. We divide them out, and we're left with A to the 2nd. Again, X times X times X, 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 divided by X to the 3rd. So again, they divide out, because anything it's dividing by itself is 1, and we're left with X to the 4th. So then again, that is 7 minus 3 to give us 4. This is what we call the quotient of powers, because we are dividing powers, and when we divide powers, we subtract our exponents. So this would become m minus n. So use the quotient of powers to rewrite it as a single power. So we have a to the 11 thirds minus 2 thirds. So 11 minus 2 is 9 thirds, which is a to the 3rd. So the product and quotient properties of exponent can be used to simplify expressions. So if we have 2x to the 5th times 5x to the 4th, multiplying the coefficients 2 and 5 go together, and then the bases are the same of our x to the 5th and x to the 4th. And so if we add 5 plus 4, we get 9. So 10x to the 9th is the simplified version of 2x to the 5th times 5x to the 4th. And here's another example for the quotient property. So we have a 2 in our numerator, we have a 1 as our coefficient in the denominator, so 2 divided by 1 is still 2, so it stays in our numerator. And then like terms, so x to the 5th over x, again that's an exponent of 1, so 5 minus 1 is 4, and then 4 minus 2 for the y's is 2. So let's try these here. So we're multiplying 4 times negative 2 is negative 8. X to the first, whoops, that doesn't look like a first. X to the first plus, or times x to the second is 1 plus 2. So that gives us 3. Y to the fourth times y to the 5th is y to the 9th. And then this division, 2 divided by 4 is 1/2. A squared divided by a to the 1 is a. B to the 5th over b to the 2nd is b to the 3rd, and c divided by c cancels out. So we would have 1a b to the 3rd over 2, or you could leave the 1 off and say a b to the 3rd over 2. On c, we have 6y to the 3rd divided by 18x times 2x to the y, or excuse me, x times y. So if we put this over 1, we now have 6 times 2, which is 12. Y to the 3rd is like y, which is a 1, so we still have an x for this one, and then 3 plus 1 is 4. And then our denominator is 18x times 1, which is 18x. Then from there we can reduce. So 12 and 18 will both be reduced by 6, so we would have 2/3. And then x divided by x would cancel out, and we would be left with y to the 4th. So 2y to the 4th over 3 would be our final answer. Hit pause on the computer or on your video and try the check for understanding, and then once you're done, come back and check your answers. Alright, so now that you've paused, let's check your answers. So this one would be 15y to the 3rd, z to the 3rd, because both of those are 1s, so we would add the 2 plus 1. For the division, 21 divided by 7 is 3, f to the 2nd divided by f is f to the 1, and g to the 7/4 minus 3/4 is 4/4, which is 1, so it would be g, and we would have a denominator of 1, but you don't have to write that 1. A growler has a mass of 243 kilograms and a volume of 27 cubic meters. Compute the density of the iceberg by completing the following. Write your answer using a power of 3. So 3 to the 5th divided by 3 to the 2nd, 3 to the 3rd is 3 to the 2nd, because 5 minus 3 is 2. Alright, and then for the lesson practice, again, pause your video and then try these, and then come back and check your work. Alright, so which expression has a greater value? Explain your reasoning. So 2 to the 3rd times 2 to the 5th would become 2 to the 8th. And 4 to the 7th divided by 4 to the 3rd would become 4 to the 4th. So 2 to the 8th is 2 times itself, 8 times. So if we are multiplying out 2 to the 8th, we've got 2 times 2 is 4, times 2 is 8, times 2 is 16, 1, 2, 3, 4, times 2 is 32, times 2 is 64, so that's 1, 2, 3, 4, 5, 6 times, and we've got to go 2 more, so 64 times 2 is 128, and 128 times 2 would be 256. And then 4 to the 4th would be 4 times 4, which is 16, and then 16 times 16 would give us 16 times 16, so we've got 6, 36, 6 times 1 is 6, plus 3 is 9, 0, 6 times 1 is 6, 1 times 1 is 1, so 6, we've got 5, 1, so 256. So the greater one would be neither, they're both equal. And if we look at that instead of actually multiplying it out, do you see that we could rewrite 4 to the 4th as a power of 2? And so 4 to the 4th, if I break down the 4, they would be double the amount of 2, so it would be the same as 2 to the 8th. The mass of an object is x to the 15th grams. The volume is x to the 9th. What's the object's density? So mass over volume, so we've got x to the 15th divided by x to the 9th, and 15 minus 9 is 6, so x to the 6 would be our density. The density of an object is y to the 10th. Its volume is y to the 4th. What's its mass? So density equals mass over volume, and in this case, the density is y to the 2nd, and the mass is what we don't know, but the volume is y to the 4th. So we're actually multiplying y to the 10th times y to the 4th, which means we're adding the exponents. So the overall answer would be y to the 14th. And then simplifying the expression, 3x to the 3rd plus, or times 3x to the 7/3. So 1/3 plus 7/3 is 8/3. So far, and we'll go down here, we've got 3x to the 8/3. And then we're going to divide that by 3x to the 2/3. And we're going to subtract 8/3 minus 2/3, which is 6/3, and 6 divided by 3 is 2. So our final answer would be 3x to the 2nd. So Tanika asked Toby to multiply the expression 8 to the 7th. So we're going to mark this off so we know that we're working over here. To multiply the expression 8 to the 7th times 8 to the 3rd times 8 to the 2nd, Toby says he doesn't know how to do it because he believes the product of powers property works with only 2 exponential terms. And this problem has 3. Explain how Toby could use the product of powers property with 3 exponential terms. It's the exact same, all the bases are the same, so just add the exponents. So 7 plus 3 is 10, 10 plus 2 is 12. So the final answer would be 8 to the 12th.